Guys, Mr. Bowman here again, just going to do another chemistry lesson with you. Again, we are looking at higher chemistry, so it's only for those who would be doing higher or triple papers. We're going to be looking at what is a mole and how do we use it in chemistry. Obviously, I'm not talking about the mole and animal, talking about have a think about the starter. Again, it's another one that I'm not necessarily expecting you to know the answer to, but to have a think. How could we tell how many molecules of water there are in the beaker? Okay, so if you want to pause it and have a go, see if you can figure out how we might be able to do that, then brilliant. Otherwise, I'm going to tell you the answer now. It is going to be 6.02 times 10 to the 23. Okay, or I'm not going to say that number with all the zeros on there, so if you want to have a go, feel free. That is a number called Avogadro's constant, and that's what we're going to look at in this lesson. Okay, so as I said, the first specification point we're going to look at is Avogadro's constant, and then the second part is going to be to do with moles and particles and how we can work out the number of moles and particles. Okay, so lots of calculations in this lesson. So first of all, as I said, the mole is a measurement that is used in chemistry. It's always the same amount, and we can use it to work out ratios in an equation. Okay, so for example, if I had 2 magnesiums there, that means I've got 2 moles of magnesium. No one in front, I've got 1 mole of oxygen, and that produces 2 moles of magnesium oxide. Okay, so this is a ratio, so it might not necessarily be 2 moles of magnesium. Okay, it might be that I have 3 moles of magnesium, but it works in a ratio. So 3 moles of magnesium would react with 1.5 moles of oxygen, okay, because it's half, it's a ratio, it's 2 to 1. And the ratio of the moles of magnesium to the moles of magnesium oxide, there is 2 to 2, which is 1 to 1. So if I had 3 moles of magnesium, 3 moles of magnesium oxide would be produced. Okay, hopefully that makes sense to you guys. So as I said, 1 mole of a substance is always the same in the number of particles that it has. Okay, it contains 6.02 times 10 to the power of 23 particles. This is known as Avogadro's constant, or Avogadro's number. Okay, and that means that if I had 1 mole of a particular substance, it would always contain that many molecules. Okay, so 1 mole of vinegar would contain 6.02 times 10 to the 23 molecules. Same number of molecules if I had 1 mole of salt, 1 mole of carbon, whatever it was. Okay. So if I had 2 moles of a substance, hopefully you'd be able to work out how many molecules there would be with that. So hopefully you've had a quick go at that. All we would do is times it by 2. Okay, so it'd work out at 12.04 times 10 to the power of 23. However, we don't actually write it with 1 decimal there, so it'd be 1.204 times 10 to the 24. Okay, 2 formulas you need to know and be able to use. I would recommend you writing both of these down, both these triangles. If you struggle to use a triangle, then make sure you write out the full formula as well for every single option. Okay, so for example, moles equals mass divided by mR. So the mR is the relative formula mass, okay, or the molecular mass. So if I had, for example, carbon dioxide, So carbon has got an atomic mass of 12 and oxygen has got an atomic mass of 16. I would add them up. So carbon dioxide is 1 carbon and 2 oxygens. Okay, so you'd add them up and that would give you your relative formula mass. Then the other equation that we have is going to be to do with the particles and Avogadro's constant. So if I wanted to work out the number of particles, I would do the number of moles times by Avogadro's constant. Okay, or if I know the number of particles for some reason, I would do, and I wanted to work out the number of moles, then I would do the number of particles divided by Avogadro's constant. Okay, a couple of examples here. I suggest you pause the video, have a go at doing both of these, and see how you get on. As the first example, calculate the number of moles of carbon dioxide molecules in 88 grams of carbon dioxide. And the second example, calculate the number of ammonia molecules in 2.5 moles of ammonia. Okay, so pause the video and have a go. Use the formulas, I've given them to you there again, and have a go. Okay, so example 1. Now the calculation that we need to use for this is going to be moles equals mass divided by MR. Okay, it's asking you to calculate the number of moles. Now we need to work out the MR of carbon dioxide. So as I said before, carbon has got an atomic mass of 12 and oxygen has got an atomic mass of 16. So I need 2 lots of 16, so it's 32, plus the 12, okay, so it'll be 44. That is going to be our MR of carbon dioxide, and we've got 88 grams of carbon dioxide. So we do the mass, 88 divided by the MR, 44. 88 divided by 44 is going to be 2. So we've got 2 moles of carbon dioxide. Example 2. Calculate the number of ammonia molecules in 2.5 moles of ammonia. So it's asking us to work out the number of molecules or the number of particles. So we do the number of particles equals the number of moles, which is 2.5, times by Avogadro's constant. Now, Avogadro's constant is always going to be the same. Remember, it's 6.02 times 10 to the 23. So if we do that, do 2.5 times by 6.02 times 10 to the 23, and it works out at 1.505 times 10 to the 24. Okay, if you get 15.05 times 10 to the 23, then you need to change it. You need to move it along 1, so it becomes 1.505 times 10 to the 24. Okay, we keep it to being one whole number before the decimal. Okay, true or false? Pause the video, have a go at some of these questions. Okay, sorry, have a go at these questions, see how you get on. Okay, check your answers, see how you got on. Hopefully you managed to get all of those done and correct. Right, now we're going to do some questions, do some harder questions. One thing that I didn't actually go into that I will do, I'm just going to go back a few slides. So if we go to this slide here, so in the red box you see it says 1 mole of a substance contains an equal amount of particles as there are atoms in 12 grams of the isotope carbon-12. Okay, so carbon has got an atomic mass of 12 and that means that 1 mole of carbon-12 will weigh 12 grams. Okay, it makes it really easy. So on a periodic table, the atomic mass, so for example, let's say oxygen, the atomic mass of oxygen is 16. If I have 1 mole of oxygen, it will weigh 16 grams. All right? Or if I have 1 mole of the molecule oxygen, so O2, then that means it will weigh 32 grams. So I've got 2 lots of the oxygen. Okay, so Avogadro's constant is 6.02 times 10 to the 23 of the molecule. Okay, so 1 mole of O2 will weigh 32 grams. Okay, so it's a really good way for us to know how much something will actually weigh. So if you have a go at these questions here for me, again, pause the video, write down your answers, see how you get on. Okay, you will need to use a periodic table for these questions. Okay, I'm going to go on to the next slide now. So now they start to get a little bit harder and you'll need to use the equations for these questions. So again, pause the video and have a go. I've given you the formulas for the different compounds that I've put into it. Again, use a periodic table. Okay, we're going to move on and look at the answers. So make sure you've had a go at all these questions as best as you can. Right, so first question. All we needed to do is use the periodic table. As I said a minute ago, the atomic mass will give us the actual mass of it if you had 1 mole of each of the following. So sodium will be 23 grams, helium's 4 grams, bromine is going to be 2 times 80, so it'll be 160 grams. And potassium oxide, which is K2O, so we would do 2 times 39, because potassium has got a mass of 39, and then we add on the oxygen, and it gives us a total of 94 grams. Hopefully you got all of those correct, and that wasn't too challenging for you. Now the second question, we need the formula. Okay, moles equals mass divided by the atomic mass or the relative formula mass. Okay, so A, 19.5 grams of potassium. So we do the mass, 19.5, divided by the atomic mass, so divided by 39, which equals 0.5 moles. And B, we've got 76.8 grams of sulfur dioxide. So we do that mass divided by the relative formula mass, which is going to be 64, and that gives us the answer of 1.2 moles. Right, so the next set of questions, we've got number 3, how much would the following weigh in grams? Okay, so the mass equals moles times by MR. That's the equation we need to use on this one. Okay, so like the last one, but we rearranged the equation this time. So mass equals moles times MR, our relative formula mass. So A, 0.5 moles of magnesium oxide. So we do 0.5 times by the relative formula mass of magnesium oxide, which is 40. So that means the mass, how much it weighs, is going to be 20 grams. 1.4 moles of calcium hydroxide. So this one's a little bit more complicated because we've got brackets involved. But if you've got a little 2 or a little number outside brackets, that means you apply that number to everything inside the brackets. So oxygen is going to be 16 for the atomic mass, and hydrogen is 1. So I would add those together, which is 17, and times it by 2. Okay, it's going to be 34, and then you add on the 40 from calcium. So the answer there is going to be 74 grams. Sorry, and then you would need to times that by 1.4, which I haven't put on there. But the answer for that is going to be 74 times by 1.4. So your answer in grams is going to be 103.6, not 74 grams. Okay, so it'd be the moles, which is 1.4, times by the MR, which is 74, which equals 103.6 grams. Okay, it's my mistake. Right, number 4. How many atoms are there in each of the following? So the equation we need to use for this one is going to be the number of particles equals Avogadro's constant times by the moles. Okay, so number of particles in 0.8 moles of nickel. Okay, so nickel. Okay, so number of particles, Avogadro's constant, which is going to be 6.02 times 10 to the 23 times by 0.8, which equals 4.8 times 10 to the 23. Then 2 moles of sodium chloride, 6.02 times 10 to the 23 times by 2, which equals 1.2 times 10 to the 24. Okay, final question. How many molecules are there in 27.2 grams of ammonia? Now this question we use both of the equations. Okay, so it's a little bit more tricky and would get you quite a few marks in an exam. So for this question, we would work out the relative formula mass of ammonia. So we've got 1 nitrogen, which is going to have a mass of 14, and we've got 3 hydrogens, which is going to be 3. Okay, add them together is 17. So we do the moles equals mass divided by MR. So 27.2 divided by 17, which equals 1.6 moles. Then we can use that to work out the number of molecules. So we do Avogadro's constant times by 1.6, which equals 9.6 times 10 to the power of 23. I know this is quite difficult. There's lots of calculations to use, but hopefully you've understood most of it, and I can go on and set some more questions for this if you would like. All right. Hopefully that's helped and you've understood the higher part of this chemistry lesson. Thank you. Bye.